All right, welcome back, students. This will be your notes for light and matter. Through this video, you can pause anytime, take notes, draw pictures, or go back and hear it again. You can even take a break and come back to it when you're ready. As you go through, make note of any questions that you have so that we can go over it tomorrow in class. We are now going to be moving into more detail about light and color. Most of this will be review with a bit of new thrown in. If you feel that you fully understand the parts that are review, you do not have to write it down. However, all the new stuff you should write down in the form of notes on pages 34, 35, and 36 of your notebook. Plus, a little review never hurt anybody, and you do have a test coming up. As you already know, light is an electromagnetic wave, which means does not need a medium to travel, but it can travel one as well. That's why light can travel in space where there is no medium, as well as here on Earth where we have a medium of air. We also learned that all electromagnetic waves are transverse, meaning they move up and down while the wave moves side to side, or simply perpendicular. We will be focusing on the part called visible light of the EM spectrum. This is the only light that humans are able to see, which is why it's called visible. To better understand how light behaves, let's review some interactions using just light for examples. The first one we will review is reflection. Remember, reflection is when light bounces back after hitting a barrier it cannot pass through, such as a mirror or a lake. Remember that the law of reflection states that the reflected light will bounce back at the same angle as it hit the surface with. In other words, the reflected angle, or the angle of reflection, equals the angle of incidence. Alright, this is new. You are all familiar by now with light reflecting at the same angle. This is called regular reflection. It's what we've been talking about. It happens when a beam of light hits a smooth surface such as a mirror or a smooth lake and bounces off at the same angle as it hit. This is why you can see reflections on that surface. However, if the surface is rough or bumpy, light reflects at many different angles in all different directions. This is called diffuse reflection. This is the reason why you don't see a reflection on a wall, because not all of the reflected light is bouncing into your eyes. These pictures are very good representations of what this is talking about, and I definitely encourage you to draw these with a simple explanation of no reflection, this one gets a reflection. We've already discussed a little bit of how and why we can see due to the reflecting light, but we can also see some objects because they produce light. Objects that produce light are called luminous. These are things such as the sun, light bulbs, fire. These objects we see because they produce their own light. Most objects, however, are seen because they reflect light. These are called illuminated, and they only are visible because they reflect light off of the object and into your eyes shown here. In other words, if there was no light source to be able to show on an object and reflect it back into your eyes, you would not be able to see it. Think about closing your eyes and being in a very, very dark room. You can't see anything because there's no light to reflect off of objects. There are two interactions that are geared more toward light than other waves. We mentioned absorption with sound, however, it has a bigger impact with light. Absorption is when light energy goes into an object or a particle like it's being engulfed, and it's converted into heat. Everyone think of a light beam from a flashlight for this next picture I'm going to draw for you. If I take my flashlight and I give you a flashlight, sorry, my flashlight's not that good, and we have particles in the air. Have you ever noticed that when you shine a flashlight beam, the light gets dimmer as it gets further away from the actual source? Has less power to it? Well, this is why. As light travels out from the source, some of the light hits different particles in the air. Now this could be dust, it could be air, could be water particles. Some of them will get absorbed in the particle. The rest of them travel on past the particle and through your destination. Some get absorbed and some move on. This is why your flashlight beam seems dimmer or less power further away from your light source. The other light interaction is called scattering. This happens when light hits an object and changes the light's direction. Let's think about our flashlight again. We already said it gets dimmer, but do you also notice that the beam spreads out from the source? Here is what's happening. Taking my flashlight again. With the beam of light, we still have our particles of dust, water, air in the air. As our flashlight beam comes out and hits this particle, it's scattering the light into a wide beam. The light is traveling in many different directions and is no longer going straight. It's now going in several different directions out of your one light beam hitting it. When light collides with a particle in the air, the light scatters, just as it does as it hits a bumpy barrier. This is also why the sky is blue. Shorter wavelengths scatter much more than longer wavelengths. Blue, as we've already talked about, has a shorter wavelength on the visible light spectrum, which is why it scatters more and we see blue being in the sky. Alright, back to review. Remember, refraction is the bending of light as it passes from one medium to another. Light refracts because light travels at different speeds in different mediums. Fastest is in space, where there is no medium. You've heard of as the speed of light. That's in space. It's a little bit slower in air, then it's a little bit slower in water, and it's the slowest through a solid material. Refraction is what makes optical illusions. Your brain visualizes light traveling in a straight line. Instead, when it hits a different medium, light bends. So this poor cat actually thinks the fish is a higher height than what it actually is. It's really down here. So this is where your optical illusions come from. Think about if you've ever been at a lake or a pool and you're trying to dive for those swim divers, the diver sticks, or trying to catch a fish with your hand. You think it's where you see it, but it's really a little bit deeper. You won't be able to touch it because you're not seeing it where it really is. Refraction of light is also responsible for rainbows, or separating color. The light we see is called white light. White light is all the wavelengths of the rainbow, or rather, the visible light spectrum. The different wavelengths of visible light is what we see as different colors. You can see here white light is hitting a prism in this case. It's refracting when it comes in and refracting again when it comes out. This refraction or bending causes us to see all the different wavelengths of white light. We will come back to this a little bit later. Right now you need to know that separating colors is due to refraction and that white light has all your colors of your rainbow. Alright, more review. Remember, diffraction is the bending of waves around a barrier or through an opening. It depends on wavelength and size of barrier. Light waves diffract the most when the barrier or opening is the same size as the wavelength or smaller. The wavelengths of visible light is very small, 100 times thinner than a human hair, in case you were interested. So light does not diffract very much, and we can't really see its effects. For example, you can't see objects around a corner, but diffraction of light can be seen coming around clouds or during a solar eclipse, such as seen here and seen here. You can see it trying to come around the object, but it's not coming through the object. Diffraction is where you also see with shadows. That's why your shadows are blurry at the edges. This is when light is trying to come around an object, such as you, and it's bending around to meet or pass the obstacle. That's why you're fuzzy around the edges, because light can't really pass through you and it's trying to form a solid picture behind you. Alright, last of the review, interference. Remember, there are two types of interference, constructive, destructive. With light, constructive interference gives off a more intense or brighter light, while destructive gives a weaker or dimmer light. This picture here shows that light, when it's brighter, is constructive due to the two light waves combining, whereas on the edges it's dimmer, where the light waves are colliding in opposite directions. For this, all you need to know is constructive bright, destructive dim. From here on out, this is all new information. Now that we have reviewed the interactions with light, we can now discuss how light interacts with matter, which is the stuff our world is made out of. Light can interact with matter in three ways. It can be reflected, absorbed, or transmitted. Reflection is where light bounces off of a surface and you can see your reflection in the window. Absorption is where light gets trapped into matter or particles, turning it into heat, which is why this glass feels warm if you're touching it. The new word is transmission. This happens when light passes completely through or almost completely through matter, which is why you can see objects outside through the glass. Light is being transmitted through the matter. Matter can also be sorted into three types based on how light is transmitted through it. Something that is transparent is when light is easily transmitted through it, or most of the light gets transmitted. In other words, it's see-through, such as glass, air, clear water, plastic, like the plastic wrap around this sandwich here. You can clearly see what's underneath it and what's in it. Translucent matter transmits some light but scatters other light. In other words, you can kind of see through it, but it's a little bit blurry, such as wax paper, frosted windows, scattered glass. You can see a little bit through it, but not all the way, such as this wax paper around the sandwich. You can kind of see what you have in there for lunch, but I can't tell if you have ham or turkey. Opaque matter does not transmit any light at all. In other words, you can't see through it, such as metal, clothing, books, and this aluminum foil. Now, you can't see what's inside here, so for all I know, you could have an apple. You could have something other than a sandwich, because I can't see what's in it. I don't know what you have in there. It's hiding. All right. Now that we have some more info on light and matter, we can talk more about color. As said before, white light contains all the wavelengths of visible light, which means it has all your colors. The color of an object depends on the wavelength of light that reaches your eyes. Light can reach your eyes after being reflected off an object or after being transmitted through an object. These two things depend on what type of matter we're looking at, and we're going to go into more detail with that in a little bit. White light breaks into all different wavelengths. Your rainbow or your spectrum is in the same order as we've discussed before, the Roy G. Biv. It goes from increasing wavelength to decreasing wavelength, as well as energy and your frequency. All right, when we think of color, we are mainly referring to opaque objects. So, when white light strikes a colored opaque object, some wavelengths of light are being absorbed and some are being reflected. The wavelengths of light that are reflected determine the color that you see, because those are the only wavelengths that reach your eyes. All other wavelengths get absorbed. In other words, all objects get hit by white light, but we only see the color of wavelength, or the wavelength of color that is reflected, such as this blue smiley face. White light is hitting this object. However, due to chemicals or compounds inside whatever this is made out of, the only light being reflected is blue, which is why we see a blue object. Similarly, if we have a red object, still being hit with all the colors of the spectrum, white light. We see red because red is being reflected and all the other colors are being absorbed. We can do this for any color of our spectrum. If the object is yellow, that means yellow is being reflected off the object. Red, orange, green, blue, indigo, and violet are being absorbed. Well, we talked about colored objects, but what about black and white things? When you see a white object, this means that all the wavelengths of color are being reflected, since white light contains all colors. So red, orange, yellow, green, blue, indigo, and violet make up white light. Since we're seeing a white object, all of these colors are being reflected and none are being absorbed. Just the opposite is true for a black object. It means that all wavelengths of color are being absorbed. White light is going into an object and nothing is being reflected. Everything is being absorbed. This is why you feel warmer when wearing black, because it absorbs light and converts it all into heat. You're much cooler wearing something white because you are reflecting all of the wavelengths and not absorbing any light and therefore not taking in any heat energy. Okay, we now know that color is determined by what is reflected for opaque objects. But this only applies to opaque things. Transparent and translucent things are a little bit different. The color of transparent and translucent objects depends on the color that is transmitted through the object. For example, plain window glass, such as you see in your house or in your car, is colorless or clear in white light because it transmits all colors, whereas the Sprite bottle is green because it transmits green light and it absorbs all the others. This can be true for any colored thing that you can see through. It transmits that color and absorbs all the others. So to review, opaque color is reflected, transparent and translucent color is transmitted. Think of the 3 T's. Transmitted equals transparent and translucent. All right, that's it for light and matter. Please either send me questions or that you have or bring them to class tomorrow so we can go over any that you need, and I will see you tomorrow.